Hello class, this is a video tutorial on the proofs of extension identities part 3. So similar to the other identities, we can merely use these identities without knowing the following proofs I'm about to demonstrate. So for the t formula, if we let the expression t equal tan equals a on 2, so a half angle for tan, then we can say that sine a is equal to 2t over 1 plus t squared. Cos a is 1 minus t squared over 1 plus t squared. And tan a is equal to 2t over 1 minus t squared. So let's go about proving these three identities. So we're going to use the double angle identity for tan. You can check this in the previous videos that tan 2a is equal to 2 tan a over 1 minus tan squared a. And from here, we're going to let a equal a on 2. So first, we're going to let this a become a over 2. Same with these. So we get 2a, but since it's a on 2, it just becomes a. So it's 2 times a on 2. So these two cancel, leaving us with tan a. And for these, we're going to let tan a on 2 equal t. So tan a on 2 is t. So that's just going to be 2t. 1 minus tan squared a on 2 becomes t squared. So that is the proof for the tan. Okay, so that's not too difficult, I hope. Now from here, we're going to consider this as a basic right angle triangle, and we're going to use this to prove sine a and cos a in terms of t. So since we have tan a equals 2t over 1 minus t squared, that is adjacent over hypotenuse. So with that some angle A, we have a right angle triangle. From the given angle A, adjacent over hypotenuse, 2t over 1 minus t squared. Now from here, initially, this is just x. We don't know what it is just yet. But I'll show you how we can find that length there, 1 plus t squared. In short, it's Pythagoras Theorem using these two values. So we get x squared equals a squared plus b squared, a squared plus b squared. Focusing on this, expanding this, square the first, square the last, 2 times the product of the middle. So when we expand this expression, we get this. Expanding this expression, it's not too difficult, that's 4t squared. From here we collect like terms, minus 2t squared plus 4t squared is plus 2t squared. This is rather difficult, but you can see that this is a perfect square. It's a quadratic where you can factorize it to become this. That's t squared plus 1 all squared. That's equal to x squared, which is what we initially tried to calculate. Take the square root of both sides, and we're left with x equaling t squared plus 1. Now from here, just use basic trigonometry once again. Sine is opposite over hypotenuse, and cos is adjacent over hypotenuse. So from A, opposite over hypotenuse, that's 2t over 1 plus t squared. And for cos, it's adjacent over hypotenuse. That's 1 minus t squared over hypotenuse, 1 plus t squared. And that there's the proof for these three identities. So I hope to see you in the next video where we actually apply these. Hope to see you then. Best of luck.